In this video, we are going to study about the stability of a coordination compound. What do you mean by stability of a coordination compound? The stability of a coordination compound refers to the extent up to which it exists in solution as the coordination sphere. So, as long as the compound can exist in its coordination sphere, you can say that the compound is stable. Now, what do you mean by stability constant? So, we are going to study the term stability constant. Now, the stability of a compound is measured in terms of stability constant, and it is actually the magnitude of equilibrium constant for the formation of the complex. We know how to write the equilibrium constant K for a reaction. So, the stability constant also is actually the magnitude. Its magnitude is same as equilibrium constant. Okay, now there are two types of stability constant. The first type is called stepwise stability constant. So, the first type of stability constant is stepwise stability constant, which is denoted by Kn. Now, we know that a coordination compound is formed by the addition of ligand to the metal, and the ligands are not added in a single step, it is added in several steps. So, for each step we get an expression for the stability constant, which is same as the equilibrium constant K. So, that is known as the stepwise stability constant. That is complex. Stepwise stability constant means the complex is formed by the stepwise addition of ligand to the metal atom, and the equilibrium constant for every step is known as the stepwise stability constant, and it is denoted by Kn, where n is equal to 1, 2, 3, etc. to infinity. Now, the second type of stability constant is overall stability constant. Overall stability constant, which is denoted by beta. And overall stability constant means the equilibrium constant for the overall reaction for the formation of a complex is known as overall stability constant, and it is denoted by beta. Okay, now I will give an example. We are going to write the formation of the compound Ml4. Ml4. So, this is the compound that we are going to get. So, I told you the ligand, there are 4 ligands, but the 4 ligands are not added in a single step, it is added in different steps. So, several steps, and here we will have 4 steps because it is 4 ligands added. So, we can write the first step as metal plus ligand gives Ml. And you can write the stepwise stability constant for this reaction. Stepwise stability constant, it is denoted by Kn. In this case, it is K1 because this is the first step. So, K1 will be equal to concentration of Ml divided by molar concentration of metal into molar concentration of ligand. Now, you know that this is the expression for equilibrium constant. What is the expression for equilibrium constant? It is the product of molar concentration of the products to the molar concentration of the reactant. So, here this is the expression for K1. Here K1 is called stepwise stability constant, which is written in the same way as the expression for equilibrium constant. Now, the second step for this reaction is Ml plus ligand, one more second ligand will add, giving Ml2. So, we have here K2, stepwise stability constant K2 will be equal to Ml2 divided by concentration of Ml into concentration of ligand. Now, the third step is the addition of third ligand to Ml2. So, Ml2 plus ligand giving Ml3. So, here we have K3, which is equal to concentration of Ml3 divided by molar concentration of Ml2 into molar concentration of ligand. Now next we have Ml3 plus L in equilibrium giving Ml4. So here we have the expression for stability constant, stepwise stability constant, which is K4, which is equal to concentration of Ml4 divided by concentration of Ml3 into ligand. Now I am going to write the overall reaction. The overall reaction will be M plus 4L in equilibrium giving Ml4. Now we know that for overall reaction we have the overall stability constant denoted by beta. So what is the expression for beta here? It will be molar concentration of Ml4 divided by molar concentration of metal into molar concentration of ligand raised to 4. Okay, so this is how we represent the overall stability constant. Now, if you look at these expressions, that is the stepwise stability constant denoted by K1, K2, K3 and K4, and overall stability constant denoted by beta. Now, in this case it is beta 4 because we have 4 ligands added or 4 steps. Now, you can see a relation between beta 4 and stepwise stability constant. And the relation is, you can write it as beta 4 will be equal to K1 into K2 into K3 into K4. Okay, or you can write, if the overall stability constant is denoted by beta n, then beta n will be equal to K1 into K2 into K3 into etc. to Kn. So this is how the overall stability constant and stepwise stability constant is related. Now I'll give you an example, that is formation of the complex CuNH3 4 times 2 plus. You can write the overall equation for the formation of this complex as copper 2 plus 4NH3 gives CuNH3 4 times 2 plus. Now you can write the expression for overall stability constant. Beta 4 is equal to molar concentration of CuNH3 4 times 2 plus divided by molar concentration of Cu2 plus into concentration of NH3 raised to 4. Now you can also write the stepwise stability constant. For that you have to write the stepwise equations for this reaction. So how will you write the stepwise equation for this reaction? The first will be Cu2 plus 1 ammonia will get added and you get CuNH3 2 plus, and you can write the expression for K1 stepwise stability constant for this, which is equal to CuNH3 2 plus divided by concentration of Cu2 plus into concentration of NH3. Okay. Now, same way you can write the expression for K2, K3, K4, and finally you get an expression for overall stability constant, that is beta 4. I'll show you one more, that is for K2. How will you show for K2? K2 to CuNH3 2 plus, you are adding one more ammonia molecule. So what will be the product? CuNH3 twice 2 plus. For this you can write the expression for K2. What is the expression for K2? CuNH3 twice 2 plus divided by molar concentration of CuNH3 2 plus into molar concentration of ammonia. Okay, similar way you can write the expression for K3 and K4 also. And you can see that this overall stability constant and stepwise stability constant are related to each other by the expression beta n is equal to K1 into K2 into K3 etc. to Kn. Now here this is the formation of the complex. Okay, so formation of the complex, we can say there is association taking place. Suppose the complex is undergoing dissociation. There is dissociation instead of association. Then how can you write that overall equation for that CuNH3 4 times 2 plus dissociation means you can write the equation like this. CuNH3 4 times 2 plus will dissociate into Cu2 plus 4NH3. So here you can see the complex is getting dissociated into Cu2 plus and NH3. So in this case we don't have the stability constant. Here we have something called instability constant. Instability constant, or it is also called dissociation constant. And instability constant or dissociation constant is denoted by Ki. I represents instability constant. So how will you write the expression for this instability constant for this reaction? Ki will be equal to concentration of Cu2 plus into concentration of NH3 raised to 4 divided by concentration of CuNH3 4 times 2 plus. So you can see this is the expression for the instability constant, and stability constant overall expression will be the reverse of this. That is, you can see I have written here the expression for the stability constant. You can see here this is the expression for stability constant for this reaction, and instability constant will be the reciprocal of this expression. You can see here this is the expression for the instability constant. So you can say that instability constant Ki is the reciprocal of stability constant, that is beta, or you can write the expression as beta is equal to 1 by Ki. So instability constant is the reciprocal of stability constant. Now we have a problem question here. It's an in-text question. I'll read out the problem question. The question is, calculate the overall complex dissociation equilibrium constant. Complex dissociation equilibrium constant means we have to find Ki, instability constant, for CuNH3 4 times 2 plus, given that beta for the reaction is 2.1 into 10 raised to 13. So beta is given. What is the value of beta given in the question? Beta is the overall constant, stability constant. Beta value is 2.1 into 10 raised to 13. You have to find Ki. So Ki will be equal to 1 by beta. Here beta 4 is given. So 1 by beta 4, which is equal to 1 by 2.1 into 10 raised to 13, which is equal to 4.7 into 10 raised to minus 14. So this is how we find the overall stability constant, or the overall instability constant is given. You can find overall stability constant, or the other way also. Okay, so this is about the stability of coordination compounds, where we have two types of stability constant. One is stepwise stability constant and the other is overall stability constant. And if there is dissociation, then we have instability constant or dissociation constant. And the instability constant is the reciprocal of overall stability constant beta. Thank you.